All right, today's lesson is on solving a system of equations using graphing. So a system of equations is a set of two or more linear equations. So it's going to look something like 3x plus 2 equals y and 4x plus 7 equals y. So just like normal equations that you guys are used to seeing, but there's going to be two of them. Since there's two of them, we're going to have kind of two answers, but our answers are the two coordinates, x comma y. So whenever we're looking for the solution to a system of equations, it's going to be an ordered pair. So don't forget to write it as an ordered pair with parentheses around it. Everyone always forgets parentheses for some reason. So the parentheses basically mean that that's where the two lines cross on a graph. So today when we're doing graphing, you guys will see where exactly they cross. So in these examples, we're just saying whether an ordered pair is a solution. So for the first one, we've got the ordered pair 3, 1. And I want to know if that's where the two lines x plus 3y equals 6 and 4x minus 5y equals 7 cross. So the way to figure out if that's where they cross is you plug those two numbers in, the 3 and the 1, for the x and the y in each equation. And if the equations are true, then that's where they cross. So if you're given the answer first, it's a lot easier because you just basically plug in those numbers for x and y. So I'm going to use colors to represent that. So for the first one, we have 3 plus 3 times 1 equals 6, which ends up being 3 plus 3. And so we get 6 on both sides, which means we're good for the first equation. Then we check the second equation, and we get 4 times 3 minus 5 times 1 equals 7, which is 12 minus 5, and so we get 7 on both sides. Since it's true for both equations, then we know that that is the solution. For the next one, we have the coordinates 6, negative 2 in the equations 3x minus 2y equals 14 and 5x minus y equals 32. And so we're going to plug in 6 for the x's, negative 2 for the y's, and see if they equal what they're supposed to. So we get 18 plus 4 because that was a double negative. 22 does not equal 14, so we know that 6 negative 2 is not a solution to the first equation. And since it's not a solution to that one, that means it's not a solution to both. So now let's actually find that coordinate instead of having it given to us. So we're finding out where our two lines cross. So for our first example, we have y equals 2x minus 3. And the second one, we have y equals x minus 1. They're both in slope-intercept form. So our slope for the first one, remember, is rise over run, so it's 2 over 1. Our y-intercept is negative 3. The slope of our second line is 1 over 1, and the y-intercept is negative 1. So I'm going to graph them in those two colors so you can see which line is which. It helps if you have graphing paper for this unit, obviously, because then you can see exactly where they cross. So for my red line, I'm starting at negative 3 and going up 2 over 1. For my blue line, I'm starting at -1 and going up 1 over 1. And you can see they cross at the coordinate 2, 1, so that's our solution. For the second example, we have the lines y equals 4x minus 3 and y equals 3x minus 3. So our slope for the first line is 4 over 1, and our y-intercept is -3. And the slope for the second line is 3 over 1, and the y-intercept is -3. So as you can see, they both have the same y-intercept. So whenever we graph them, they should start at the same point, and that means that's where they cross. For our third equation, our set of equations, systems of equations, we have 2x minus y equals 3 and y equals 2x minus 5. That first equation is in standard form, so if you guys remember how to graph standard form, we find the x and y intercepts. So to find the x-intercept, we plug in 0 for y, and the y-intercept, we plug in 0 for x. So when we're finding the x-intercept, we'll have 2x minus 0 equals 3, and that 0 goes away, and then we end up getting 3 over 2 for our x-intercept, which is about 1.5. For our y-intercept, we plug in 0 for x, so it's 2 times 0 minus y equals 3. Don't forget that minus makes that y negative. So we end up getting -3 for our y-intercept. For the second equation, we have a slope of 2 over 1 and a y-intercept of -5. So we'll start at -5 and go up 2 over 1. So graphing my standard form equation, I'm going to find 1.5 on the x-axis and -3 on the y-axis. And I'm going to draw a line going through those 2 points. And then for my blue line, I'm going to start at -5 and go up 2 over 1. And as you can see, these two lines are parallel, which means they're never going to cross. And whenever that happens, we write that there's no solution. For our final equation, we're going to have two equations in standard form again. So we've got x plus 2y equals 4 and x minus 2y equals 4. So we need to find the x and y intercepts. So for the first one, we're going to get x equals 4. So that's the point 4, 0. And then for the next one, we have 2y equals 4. So we get y equals 2 for the point 0, 2. For the x-intercept on the second equation, we get the same 4, 0. And our y-intercept, we're going to get 0, -2. So as you can see, they already have the same point for their x-intercepts, so that should be where they cross. So I'm going to plot each x and y-intercept. Then we can look at where they cross. I accidentally did that in the wrong color. All right, so here's our red line. And here's our blue line. And they cross at the point 4, 0. Now, if you guys remember, when we're graphing, we have a tool that we can use since we're doing online school. We can use Desmos.com. So I'm going to show you guys that all of these problems can be done on Desmos. So type in Desmos.com, go to the graphing calculator, and then you type in both equations. So we're going to do that last example. So x plus 2y equals 4, and x minus 2y equals 4. And then we can see that they cross at 4, 0. It even tells you the coordinate. So you can use that on your homework, but you have to write down, like you have to draw the graph on your sheet of paper, and it has to have the actual coordinates so I can see that you're not just drawing lines that cross. Okay, so draw the actual graphs on your piece of paper.